Gate AB is 2.1 meters wide and weighs 15 kilonewtons when submerged. It is hinged at B and rests against a smooth wall at A. Determine the water level H, which will just cause the gate to open. So here is the given figure. There are two liquids, same liquid water on the left side and on the right side. And the gate is totally submerged, so the height of the gate to be considered is 3 meters and it's 2.5 meters wide into the screen. So let's locate the centroid. The centroid of the gate is common to the left and to the right because it is totally submerged. What is not common is the center of pressure at the left where F1 acts. So here is the center of pressure for the water at the right. So F1 acts here, F2 acts here, and this distance is E sub 1 at the left, then E sub 2 at the right. Then the weight is considered, it is 15 kilonewtons, therefore its distance from the hinge B, because we sum up moment about B to open the gate, so there will be no reaction at A when the gate is about to open, is 0.9, half of 1.8. Also, to check that the height of the gate is really 3 square root of 1.8 square plus 2.4 square. So we will call this angle theta, which is also the angle of inclination of the gate. Tangent theta is 2.4 over 1.8 later in computing for E1 and E sub 2. So summation moment about B equals 0, our working equation be F1 times, because the centroid of the gate is 1.5 meters from B, 1.5 meters from A, half of 3. So therefore the moment arm of F1 is 1.5 minus E1. Then it is equal to counterclockwise moment F2, quantity 1.5 minus E sub 2 plus 15 times 0.9. So that's our working equation. And we will determine all these unknowns in this working equation here, beginning with F1, specific weight of water, barred H1 area. Barred H1 is distance from water surface at the left, vertical distance down to the centroid of area, which is here. So it is H plus half of 2.4, that's barred H1. Because this is 2.4 and this is straight line, therefore the centroid is 2.4 over 2 below A. So therefore barred H1 is H plus 2.4 over 2, and the area is 2.1 by 3 meters. 2.1 meters wide by 3 meters. So F1 is 9.81. Barred H is H plus 2.4 over 2. Area is 2.1 times 3. So F1 therefore is 61.803 quantity H plus 1.2, where 1.2 is 2.4 over 2. Then E sub 1 is height of rectangle square sine of theta over 12 barred H. Tangent theta is 2.4 over 1.8, so theta is 53.13 degrees. Then E sub 1 is height of gate 3 square sine of 53.30 degrees over 12 barred H. Barred H is H plus 1.2. Simplifying, E sub 1 is 0.6 over H plus 1.2. Then F2. F2 is specific weight of water, 9.21. Barred H for F2 is 1.2. 1.2. And this vertical distance is 2.4 over 2. So 1.2 plus 2.4 over 2, area is 2.1 times 3, same as the first because the gate is totally submerged. So F2 is 148.327 kilonewtons. E sub 2 is height of gate square sine of 53.30 degrees over 12 barred H2, where barred H2 is 2.4. So 3 square sine of 53.13 degrees over 12 times 1.2 plus 1.2. So E sub 2 is 0.25 meter. So everything is known. except for h, the only unknown. Substitute in our working equation. 61.803 quantity h plus 1.2 times quantity 1.5 minus E1, which is 0.6 over h plus 1.2 equals F2 148.327 times quantity 1.5 minus 0.25 plus 15 times 0.9. So 61.803 times 1.5 is 92.704 quantity h plus 1.2 minus 61.803 times 0.6, 37.082. Then combining these values here, that's 198.909. So we can now solve for h. 198.909 plus 37.082. The answer divided by 92.704, then minus 1.2. That's the value of h. So h is equal to 1.346 meters.